Well, hello miss, my name is Juan Fernando, you let mention, and today I'm going to talk about a little bit about my career. My career is computers and programming. Well, at it, I'm going to talk about the hardware terminology, the main memory, auxiliary memory, what are the drives, the writing algorithms using pseudocode, programming language code, the compilation process for non-Java programs, what is an object code, portability, a Java virtual machine, and the compilation process for Java programs, and also the history of Java. Well, Java is the program that we also use to develop some programs. Java has many applications with Eclipse or any others. So to know what is computer engineering, you have to know what is a computer system. A computer system are all the components that you have in your PC. Well, a CPU, a memory, keyboard, a mouse, and a scanner, a monitor, printer, a hard disk, a diskette, compact disk, and USB flash drive. That are storage devices, or auxiliary memory. Well, in hardware technology, you have to know that I/O is input and output device. Input examples from the keyboard, the mouse, the scanner, or monitor or printer, and CPU is the computer's brain. Of course, synonym of it is processor, microprocessor. And most of the popular CPUs are Core 2 Duo, this manufactured by Intel, and Athlon 64, manufactured by AMD. Well, we continue. Any computer have a main memory. When a computer performs calculation, it often needs to save intermediate results. So there's save intermediate results in the main memory storage area. Main memory is often called RAM, random access memory, in English of course, and memory contains storage boxes, and each storage box contains a piece of information. For example, if a program stores the word emu, it uses two storage boxes, one for the first half of E, then one for the second half of E, one for the first half of M, and one for the second half of M, etc. So that is the main memory that is inside of your computer. Then each of the byte storage boxes are used to store emu as a byte. So they are bytes. Computers don't understand the alphabet, and they only understand zeros and ones. So computer maps each alphabet characters to a series of 16 zeros and ones. For example, the letter E is 000000000100000101. So in storing the letter E, main memory actually stores 0000000001000101. Each of the zeros and 1 is called a bit, and each of the 8-bit groupings is a byte. So a byte is higher than a bit. The capacity of size of memory is described in terms of number of bytes. RAM capacities in typical computers range from 50,000 megabytes and to 3 gigabytes. Now, there are more. They have more memory, and they also had like 8 or 16 gigabytes. RAM is volatile. Data is lost when power is turned off. So when you turn off your computer, all the processes that you are doing are lost. Auxiliary memory. Auxiliary memory is for saving data permanently. It's not volatile. It's like your brain. Auxiliary memory comes in many different forms, the most common of which are hard disks, diskettes, compact disc, and USB flash drives. Those things are called storage devices. Storage capacities. Typical hard disk is at 18 gigabyte and up to 1 terabyte. My computer, for example, have 500 gigabyte of memory. High density 3.5 diskette 1.44 megabytes. That is the famous diskettes that now are obsolete and no one uses it, but were so common in the past. Compact disc for CD-ROMs, CD-Rs, there are like 700 megabytes, and for DVDs and DVRs that's 4.7 gigabytes up to 8.5 gigabytes. Typical USB flash drives 128 megabyte up to 64 gigabyte. That is the USB. Drives. Well, what is a drive? A drive is a mechanism that enables the computer system to access, read from, and write to data on a storage device. A disk drive is a drive for a hard disk, diskette, or CD-ROM. When using your computer, you will sometimes need to copy data from one place to another. To specify the storage media on which this data resides, you will need to use the storage method drive letters followed by the colon. Well, diskette drives are referred to as A, or hard disk drives are usually as C, or CD-ROM drives are usually referred as D or E. USB flash drives are usually referred as E or F. This is a letter you find in my PC. Well, there you have the drives. Common computer hardware vocabulary. Well, you know what this space usually means the capacity size of your hard disk. Floppy. What is floppy? Floppy is a diskette. It's in another. It's like another language. Memory, said by itself, usually means main memory or RAM. What is memory is RAM. A computer usually refers the base box, the CPU, and the main memory, the hard disk, like PC, CPU. Okay, now what we do in one programming is just using algorithm and pseudocode. So to writing algorithm with pseudocode. A program is a set of instructions that can be used to solve a problem, but that is a problem. The first step in writing a program is writing a draft of your program where you focus on the basic logic, not the specific details. The draft should include instructions that are current and logically correct, but there is no need to worry about missing minor steps and misspelling words. Such a draft program is referred to as an algorithm. For example, a cake recipe is an algorithm. Well, when you do something or you create something, it's an algorithm. Algorithms are written by pseudocode, similar to regular programming code, except that precise syntax, words, grammar, and punctuation isn't required. So you can write it like a letter to your friend or something like that. Example: write an algorithm that finds the average miles per hour value for a given car trip. You can put the sample input, starting location equal to 100, and then location equal to 200, starting time to 2 o'clock, and ending time 4 o'clock. A programming language it's a language that uses especially defined words, grammar, and punctuation that computer understands. Well, as you see, for programming we use a language, a special language, not the common as English, Spanish, or any others. It's a programming language. So some of the most popular common languages are Java, Visual Basic, C++, and Pascal, for example. A lot. Write a Java code that finds the average miles per hour value for a given car trip. That could be an example of programming language. Initially, programming language code might be harder for you to understand than pseudocode. Yeah, pseudocode is easier because it's like something you understand, and language programming is like old code, and it's a little bit hard. But after you gain experience with programming language, you may become so comfortable with it that you are able to skip the algorithm pseudocode step and start coding with the programming language directly. However, for larger programs, it recommends that you do not skip that and reset the code escape. Why? The compilation process for non-Java programs. What is the compilation? Is the resulting of the program when you compilate when you finish the writing code. And if it compilates, it works. If it don't compilate, it don't work. So the compilation. So after writing the program, you will normally want to have a computer perform the task specified by the program. Getting that to work is normally a two-step process. First, perform a compile command, and second, perform a run command. When you perform a compile command, you tell the computer to translate the programming's language instructions to a binary format, all zeros and ones. When you perform a run command, you tell the computer to read the binary format instructions and perform the tasks specified by them. A computer contains a special program called compiler that it shares the compilation programs. If you submit programming language instructions to a compiler, the compiler translates them into binary format instructions. More formally, if you submit source code to a compiler, the compiler compiles the source code and produces object code as a result. Source code is the formal term for programming language instructions, and object code is the formal term for binary format instructions. So that is compilation. It's to run the program that you are. That's that. Oh, not always do. Okay. So source code, programming language instructions, get object code, binary instructions. Programmers write source code, compilers compile the source code do, and computers run object code. Next, object code. An object code is a set of binary format instructions that can be directly run by the computer to solve a problem. A binary format instruction is made up of all zeros and ones, because computers understand only zeros and ones. Here is an example of an object code instruction: 01001111011010. That is an object code instruction. Well, this particular object code instruction is referred to as a 16-bit instruction because each of the zeros and ones is a bit, and there are 16 of them. Each object code instruction is in search of only a simple computer task. For example, an object code instruction could possibly be in search of copying a single number from some place in my memory to some place in the CPU. Programmers sometimes refer to object code as machine code. Object code is called machine code because it's written in binary, and that's what a computer machine understands. Portability. A piece of software is portable if it can be used on many different types of computer. That's what more programmers want to do. It's necessary because we are not always in the same computer. Object code is not very portable. As you know, object code is comprised of binary format instructions. Those binary format instructions are intimately tied to a particular type of computer. If you have got an object code that was created on type X computer, then the object code can run only on type X computer. The Java solution to improve portability. Java compilers don't compile all the way down to object code. Instead of that, they compile down to bytecode, which possesses the best features of both object code and source code. Like object code, bytecode use a format that works closely with computer hardware, so it runs fast. Like source code, bytecode is generic, so it can be run on any type of computer. Java Virtual Machine. How can bytecode be run on any type of computer? Well, as a Java program's bytecode runs, the bytecode is translated into object code by the computer's bytecode interpreter program. The bytecode interpreter program is known as the Java Virtual Machine, or JVM for short. The next slide shows how the JVM translates bytecode to object code. It also shows how the Java compiler translates source code to bytecode. So that is a Java virtual machine. The compilation process for Java programs. Well, you have the Java source code that converts in bytecode, and then is an object code. Well, and to end a little bit of history, the history of Java. In the early 90s, putting intelligence into home appliances was thought to be the next hot technology. Example of intelligent home appliances were coffee pots and lights that can be controlled by a computer's programs. Or televisions can be controlled by any interactive television device programs. So, anticipating a strong market for such things, Sun Microsystems in 1991 funded a research project, codenamed Green, whose goal was to develop software for intelligent home appliances. An intelligent home appliance intelligence comes from its embedded processor chips and the software that runs on the processor chips. Appliance processor chips change often because engineers continually find ways to make them smaller, less expensive, and more powerful. So chips are always a little bit, and maybe some days you couldn't see it. To handle the frequent turnover of new chips, appliance software must be extremely portable. Originally, Sun planned to use C++, the language program, for its home appliance software, but they soon realized that C++ was less than ideal because it wasn't portable enough, and it relied too heavily on hard-to-maintain things called pointers. Thus, rather than write C++ software and fight C++ inherent device deficiencies, Sun decided to develop a whole new programming language to handle its home appliance software needs. That's how Java come to life. The new language was originally named Oat for the tree that was outside project leader James Ghost's windows, but it was soon changed to Java. When the home appliance software network dried up, Java almost died before being realized. Fortunately for Java, the World Wide Web exploded in popularity, and Sun realized it could capitalize on that. Web pages have to be very portable because they can be downloaded into any type of computer. What's the standard language used in a web page? Java's programs are very portable, and they are better than HTML in terms of providing user interaction capabilities. Java's programs that are embedded in web pages are called applets. Although applets play a significant role in Java's current success, some of the other types of Java programs have surpassed applets in terms of popularity. In this course, we cover the standard edition as E Java applications. They are Java programs that run on a standard computer, a desktop or a laptop, without the need of the internet. Well, that's all that I have to talk about my career. I have to explain it. What is Java? What are the computer? What exactly what we do? We program. We make programs, and it's a hard work really. I'm so excited, so exhausted because last night I have been working until 4 a.m. This is all what I do. So I wonder you enjoyed, and thank you, and we'll see you next time.